let's get into the walkthrough for our LLMNR poisoning attack. Also, NBT-NS poisoning. LLMNR stands for Link Local Multicast Name Resolution, and the predecessor is your NB. It's not. I refer to it more NBNS for name Net BIOS name resolution, but you might see NBT dash NS, which is the same thing. All you need is your Windows server, and we can just leave it up. We don't need to do anything with it. Leave that running. You don't need any other host in the network, and our Kali machine. So as you can see, we're starting to get some information coming through here. Normal network traffic, you're gonna see your DHCP, your ARP requests, your LLMNRs, your NBT-NS. It's gonna be a few different things coming through here. These are all normal, so we can see the baseline. But what we're going to do, we want to basically sit in this network, and now we're making the assumption that I'm already in this network, that we are here, we've gotten in, so we're not going to be doing any enumeration of the network. In this example, we're going to assume that we've already done it. We've accessed the network, we're on the network, and now we're just watching this traffic, trying to find a way to capture something that's of value to us. So really quick, so you can see, if I go to log in, as you can see, I have a password that I'm going to enter here. Now the system has to send a hash to check against what I'm about to put in, and because of that, it seems great and convenient, but this hash that I'm about to try to steal means it's accessible, and using something like LLMNR or NBT-NS puts it in harm's way, and that's what we're going to try to capture. So let's go to our Kali machine. We're going to use something called Responder. I have it at user share Responder. If you just install the latest version of Kali, it's a 2022 version, this is already pre-installed and right at this address. So you'll see it just like this is a Python script here. What for this conf file, we can leave exactly the same right now, but there are times you might want to edit this depending on what you're doing. But for now, just leave it as is. So to make this really simple, we are on this machine. Let's go ahead and run Responder, and I want to look at, might want to do that. I'm going to look at the help options first. So I'm going to put on verbose so we can see what's going on. But I know the main things we're going to need are, we're going to need to know our interface. Whatever interface we're using, we're going to have to know the name of it. I believe that's really the only thing we need. There are some other options which I'm not going to use today because I don't think we're going to need those. But yeah, look in here. There's plenty of things you can do with this. So let's clear this. Now, I'm going to use root privileges for this, but let's go ahead and run Responder. Just let it run on the network. As you'll see, this is going to, you know what? Let's do a ifconfig. I need to see, okay, we're using eth0. So let's go ahead and run that. So Python 3, and we'll do a capital I for our interface, and then just type in our eth0, and I'm just going to do verbose. I don't need anything else for this. So, not like that. You don't do it like that. I might need to actually type in Responder. There we go. Okay. Now you see here that we have our poisoners, everything except DHCP. We're running that off of our host machine. In theory, it's virtualized, so we don't need to worry about that. And everything else is on except our WPAT and our auth proxy right now. Leave those as is. And everything else, this is exactly how it should look. So we gotta come down here. Now it's just listening for events. It's not going to do anything, but let's come back and look up here. We'll see that we have LLMNR. This is sending out queries. standard query, it's being resolved, but the issue would be if you actually try to head somewhere that isn't on the network. And as soon as that goes out, that's what we're looking to capture here. So as soon as any request goes out, we're going to try to capture it and have everything sent to us. So as soon as they think that we are wherever they're trying to go, they'll send us their authentication. So their NTLM version 2 hash will be sent directly to us if they try to resolve anything. So a way this might look, because this isn't an entire network with a bunch of people typing in different things, the best way I could emulate that was, let's just take our server, our domain controller, and I'm going to type in, let's type in server. There's no such thing as, I don't have a thing called server on here, so it's not going to go anywhere. But you see it asks for our credentials, even though there's no such thing as this. And if you look over here in our Wireshark, you will see, let's go back up. Let's actually, so right around the time, and let's look at our IP addresses so we can see what's going on here. So our Windows server, FE804887, and let's come down to our Kali machine, which we see we have our IPv6 as FE80. There's a bunch of zeros and then 800. Did I add the? Hold on, let me add I think I did not put the. We'll check this out in a second. As you can see, it already is doing what it needs to do. I want to confirm. Okay, that's right. It's just another 0A00. Okay, anyway. Yeah, so let's go down and we'll see what happened. And then we'll look at it in Wireshark actually right after. So here we see that we have both. And actually NBT went off first, and it's poisoning, saying it sent an answer to 1010.2.4, which is our domain controller, which is basically trying to tell our domain controller, hey, look at me. I am what you're looking for. There's no server that you can find. I am that server, because this sends out the request to everyone. And I respond and it says, okay, you're the server. Let's connect. And in order to connect, I'm like, fine, go ahead, log in, but I'm gonna need that hash, because I can't confirm you are who you say you are on this network without the hash. And then it sends the hash, and now I have it without even having to have the user enter anything. And once I have this, there's multiple things at this point that you can do with this. There's something else where we can relay this, because we don't need to crack this hash. We technically, having this hash, we can just send this over to anywhere else on the network, because this is our entry. It's looking for this. So we don't need the plain text. We could just forward this through something such as SMB relaying, NTLM relaying, which is one thing we'll do for IPv6 attacks. But for now, because we have this, let's make this a simple, straightforward thing. I'm going to copy this hash. And if you have John, which if you're using this Kali, you do. Basically, what I would do, let's actually sudo, let's just nano this, and let's say let's call 80 hash. Okay, I'm gonna copy this in. Let's save it. Okay, now that we have that hash, I might need sudo for this. Use John, and I'm gonna use John on this hash. Go ahead and enter your password. And look at that. Look how quick and easy that is. Password 1. That's obviously what we know as a password. Now, this is why it's important to not have weak passwords, because that's way too easy to crack and get this off of just sitting on the network. But I just wanted to show you how easy it is to grab that, and how easy it would be to crack that if you don't have a strong password. So, as easy as that seems, though, let's see what actually happened, and then let's also figure out how to stop it. So here, as you can see, we saw these queries going out prior, and they look like they resolved normal. There was no issue. But then here, as you can see, as these are going out, we're getting these broadcasts, a multicast, I should say. All of a sudden, you'll notice, we go down a little further, here's our address that we'll be looking for. Now, along the way, these queries seem like there's nothing problematic here. But, wait, what's this? Now it seems that we have our query and an answer. But the problem is that this answer and this address, our 1010.26, which is our attack machine, is now talking to our domain controller, telling it that that server you're looking for is here. And it now believes. So as you can see, well, now it's got to send information over, and that response is coming directly to us after that. Now the question is, how do we mitigate against this? Now, granted, you don't need to use LLMNR or NetBIOS in your environment. These really, I guess, would help if you were in maybe a subnet where you don't have a DNS server and you're using that to compensate. But this isn't a necessity. So turning them off would be the best mitigations for these. So in order to turn this off, first we're going to go to let's do LLMNR first, because both of these will act the same way. If I turn off LLMNR and not NBT, it'll just switch to NBT-NS and just say, okay, LLMNR is off, so I'll just go to my next option. So both of them have to be off if you don't want to have this happen. So let's go to our local security policy. I'm going to go into let's computer, here, security options. Oh, no. My bad. Wrong place. So let's go back. Let's go back. Come on. Oh, no. Okay, wrong thing. I'm in the wrong place. Ignore me. So we need to group policy. Let's go to edit our default. Let's go into computer configuration, policies, administrative templates, and let's go to network, DNS client, and here here we go. Turn off multicast name resolution. Now this is a little confusing. This is turn off multicast name resolution. So to turn it off, you have to enable turn off multicast name resolution. So that was the correct way to turn it off, is to enable this. You're enabling the off button, which is confusing. So there's that. Now we need to, let's go down here. Yes. So open up your network connections and let's go to our adapter options. Go ahead, right click, properties, come down here to our IPv4 and click on properties. Now if you come down here under advanced, I believe it's in okay, here we are. So here is our NetBIOS settings. You can use NetBIOS setting from the DHCP server. Yeah. What we're going to do is we're going to disable this NetBIOS over TCP/IP. We do not want to run this, so just go ahead and hit OK. And close that. And basically this is what we'll need to secure this environment, because once these two are off, I mean, we can run it again if we just want to confirm. Let's go ahead and run this. Now when we come up here, over to you, get rid of you. Let's go ahead and try to go to the server again. Our credentials now. Hopefully, oh, not good. Oh, well, you know what? So you also notice, we see this other protocol. It's multicast domain name system. It works very similar, and if you look, if we go back, I didn't mention this because I'm more familiar with LLMNR and NBT-NS, but the same thing we're dealing with mDNS. So, but we're going to treat these all the same. In order to mitigate, it's just about turning these off. Let's see Windows 10. Oh wait, Windows Server. Let's just double check. Turn off mDNS. This is where I was earlier. This is what I got. Same thing. So disable. So magic registry value. Windows that would disable mDNS and the Windows client resolver. I am not going to tell you what it is, but I will tell you why you should not rely on it. Disable mDNS. I mentioned that it's easy to implement. Okay, firewall. Okay. Okay, so inbound to block, disable the inbound. Okay, so let's pull up Windows Defender. Now it says disable within the corporate office only. Disable MDS for just Well, for this, since it's a test environment, let's just do. It says the inbound rules in Windows Defender for all public, private, and domain. This will prevent all inbound traffic being processed. But outbound, both. Okay, so this is quite the issue, because this isn't recommended to be turned off. In my environment, this won't cause any problems. But at the same time, I want to mimic something that's real. Let's see. Okay, so It says UDP-N, mDNS. Let's just go down to mDNS. Okay, so domain. All right, I'm gonna block the connection. Inbound. Okay, let's block it. I just want to try this out, see what happens. This is just a test. Okay. Let's try it out. I have a feeling that the inbound and outbound are both going to be blocked, or at least inbound. I mean outbound. Yes. Yes. Yep. Still getting mDNS. I might need to update or restart, but we're gonna do this way just to see. Outbound. I do these all together. I mean, I'm being heavy with it because I just want to make sure. I could just disable it, but let's turn all this back on eventually. Okay. So I don't believe I need to do an update, but just in case. Okay, let's try this one more time. Can I do it just in here? Okay, cool. Let me double check, make sure. What I try to do. Okay, let's go to sir. Okay. Just in case, so make sure it's not anything weird. And we're getting nothing. So now the only issue here is mDNS is off, so if you need to use it. But as you can see, these vulnerabilities are there, so I still don't recommend it. I mean, looking at how this functions, it's very easy to access. So I'm gonna have to do more research on that to really figure out what the best solution for that is, because I believe in 2019, Windows Server 2019, I do not recall if I had this issue with mDNS. I don't recall if mDNS was there in 2019. So, okay. Yep, but anyway, so that's what I wanted to do, is talk about LLMNR. We went a little bit further, added in mDNS, which was not even part of the plan, but now as we can see, it's still part of this protocol. It needs to be shut down when doing this. So hopefully this helped. Hopefully it was eye-opening. I know it opened my own eyes. So thanks for watching, and hopefully you enjoyed.